Okay, so today we're going to be looking at IUPAC naming of alkanes, alkenes, alkynes, and alcohols. The reason I wrote it like this is because the main focus is going to be on alcohols, but I am going to talk about alkanes, alkenes, and alkynes briefly. So, alkanes. Alkanes have the general formula of CN2N plus 2. They also have the suffix ane. And generally, the alkyl halide prefixes, which is going to apply to pretty much every circumstance in which we see the halide compounds. For iodine, it's iodo. For fluorine, it's fluoro. For chlorine, it's chloro. And for bromine, it's bromo. So for naming alkanes, the prefix for alkanes is going to depend on the number of carbons that you have. So for example, number of carbons and prefix. So if I have one carbon, my prefix is meth. So if I have if I have an alkane and only has one carbon and no other substituents, then what I'm going to have is methane, right? If it looks like this, that's methane. If I have a 2-carbon system, that's going to be eth. So if I have carbon, and these are all hydrogens, then this is going to be ethane. So pretty much this goes down for a while, and I would recommend knowing at least up to 12, but 20 is preferable. So alkanes, pretty straightforward, pretty easy to name. Alkenes and alkynes, also decently straightforward. I'll go over them real quick. So general formula for alkenes is going to be CnH2n. And if there are multiple bonds, so the general suffix for alkenes is ene, just like that. So pretty much what we see at the end of here is going to be our suffix for each group. But for alkenes, if you have multiple double bonds, you can specify them by, so for example, if I had 2 multiple bonds in some hydrocarbon, I would say diene. If I had 3, I would say triene, and so on. That kind of parallels our common IUPAC naming conventions with the prefixes for the substituents. And then lastly, the general formula for alkynes. It's going to look something like this. CnH2n minus 2. Right? So, and its suffix can be "-ine". So these really aren't too in-depth. They're not too hard. For MCAT, I don't even think we need to name these. Don't need to know how to name them. But it is important to be able to recognize them, especially with biochemical complexes like fatty acids. So we don't necessarily need to know them, but we do kind of need to recognize them. Okay, let's talk about alcohols. So, alcohol. A lot of important information about these, but what I'm going to start off with is the general form. So we have some parent chain, and at the end, we have an OH group. This is our alcohol, and it changes the suffix from an E with alkane to all. So it's important to know that alcohols have a somewhat high priority. They'll take priority over second degree, over double bonds and triple bonds in hydrocarbons because its oxidation state is higher than those bonds. So if I saw something like this, right, I would say this is my, since this is my first carbon, this is my second, this is my third, this is my fourth. The reason this is 1 is because, again, we want our carbons to be closest to the highest oxidized functional group. So what we're going to have is it's bute 4 ene 1 ol, something like that. Okay, so if there is a higher priority functional group, then this is going to become known as hydroxy. So its substituent name is hydroxy. Yep. And there's a couple more things, but it's important to know the common names for a lot of alcohols. These are used a lot. So 2 really important ones that have been stressed so far are 2-propanol. Propanol. So this is just going to become isopropyl alcohol. We can kind of imagine this, right? Because if this is our propane, and we have this OH on the top, it kind of looks like what we had with our isopropyl, but instead of this being blank right here, we just attach an OH to it, right? Okay. And then the second one that's pretty common is ethanol. So its common name is ethanol, but its IUPAC name is ethanol. Its common name is ethyl alcohol. Right? So that just looks something like this. Again, not too complicated. Those are just 2 things we should probably be aware of. And one other thing about alcohols is that if you have multiple alcohols, these are known as glycols and diols. So there's 2 hydroxyl groups. So these are signified with the suffix diol. Right? That's pretty self-explanatory. And there are two important diols that we need to know, 2 specific ones. These are geminal diols. Where both hydroxyl groups, so both hydroxyl groups are on the same carbon. So, for example, if we had something like this, this is a geminal diol because both of the hydroxyl groups are on the same carbon. And then we have vicinal diols, where the hydroxyl groups are on adjacent carbons. So for example, this would be a vicinal diol because the hydroxyl groups are on adjacent carbons. One important note about the geminal diols is that they almost never, or they don't really exist, at least not for a long time, because they will spontaneously dehydrate. So with the subtraction of H2O, or dehydration, This will result in the formation of a carbonyl group or a carbon double bonded to an oxygen. So these aren't super stable. They'll end up just dehydrating into this. So not really common except for in some organic mechanisms as final products. But realistically, we won't really see them too much.